Hey, welcome back. Let's start with the new section of this course. And in this section, we are going to understand variables, data types of Rust, and we'll also look into the mutability aspect while creating variables. In this section, I'll be discussing primitive data types of Rust. In later part of this course, we'll also explore more complex and user-defined data types such as structs, enums, hash maps, vectors, strings, etc. For this lecture, we'll just explore the primitive data types offered by Rust. And we'll also learn how to declare variables and also mutable and immutable nature of the variables, rules for writing legal variable names in the Rust programming language, and variable naming conventions. First, let's start with data types. Rust provides a couple of primitive data types. Primitive data types means these types are built into the language and are always available for use without the need for additional inclusion of libraries or dependencies. They can be used to perform a wide variety of operations such as mathematical calculations, or can be used for data storage. And these are the data types. Actually, they are foundation upon which more complex data structures and algorithms are built. So in Rust, these are a couple of primitive data types like integer data types, data types to represent floating point numbers, bool for Boolean data, character, arrays, slices, and tuples. Let's explore one by one. So let's first explore numerical data types to represent numerical data. Here in this table, as you can see that Rust supports data types for both signed and unsigned data representation. For example, if you consider I8, which is a data type used to represent single byte signed data, which is similar to int 8 underscore t in C. If you know about the fixed width integer data type in C, then it is exactly int 8 underscore t in C. And I16 is to represent 2 bytes of integer signed data. So likewise, I32 is there, I64 to represent signed data of 8 bytes, and there is also I128 and U128 types which were introduced in Rust version 1.26. They are intended to represent 128-bit data. And you have the unsigned counterparts of numerical data types like U8, U16, U32, U64, even you have U128. And there are platform or machine dependent data types like iSize and usize. So these are platform dependent. Their size is 4 bytes. So if you are running the application on 32-bit machine, or it could be 8 bytes on 64-bit machine. But these are fixed with integer data types. No matter in which machine you execute your program, so the size of I16 is always 2 bytes. And this is a range associated with that particular data type. And to represent floating point data, so we have got two data types here, F32, which is for single precision floating point data, and F64. This data type should be used to represent data of double precision floating point. I hope this is very simple to understand. And please note that the size of the iSize or usize variable will not change dynamically when the code is running. So everything is determined at the compile time only. When you compile the Rust code, the compiler generates machine code that is specific to the target architecture. This means that the size of the iSize is determined during the compilation process based on the target architecture, and it is fixed for the resulting executable. So the variables of type iSize or usize is often used when dealing with memory addresses or when indexing into the collection. So if you are unsure about whether to use I32 or I64, then you can simply use variables of type iSize or usize. So we'll see more on that later, and let's go to the next slide. Now let's see how to define a variable. Very simple, you just have to use the let keyword followed by the variable name and then equal sign and then the value that you want to assign to the variable. So now let's learn how to create variables in the program using the let keyword. Now let me write the main function first. Very simple, you have to use the let keyword. just write let, give a space and a variable name. Let's say value. That's a variable name. And then initialize its value to something. Let's say I initialize this to number 10. Now you may be wondering, if you are from C or C++ background, we have not mentioned the data type. So whether it is an integer data type or a float or a bool or something like that. Basically what happens in Rust is most of the time the compiler does type inferencing. So it has that intelligent built-in into the compiler that it determines the type of the variable by carefully analyzing the code and under which context the variable has been used in the program. So everything is determined at the compile time. So there is no runtime involved in deciding the data type of the variable. For example, in this simple code, the compiler by default may attribute the data type i32 to this variable. So we are not sure. Let's understand more on that a little later. Is this a legal code? This is obviously the legal code. As you can see, it compiles. Maybe there are a couple of warnings. Let's not worry about that. But this did not generate any errors. That means the data type is already derived from the compiler for this variable value. And then let's use that to do some calculation. So let's say I create a variable sum is equal to 10 plus value. Here there is another variable called sum, so to which I'm adding this number. After that, let's print the value of the sum. For that, let me use the println macro. Please note that when you use the println macro, I cannot directly print the value of the sum like this. This is like we used to do in Python, for example. So you have to create the placeholder first if you want to print the value of the variable inside the double quotes like this, and then mention the variable which you want to print, sum. Let's compile this and everything works. As you can see, even though we did not mention the data type for these variables, so this program works. And the compiler, when it analyzes this code, it derives, let's say it attaches, so let's say it attributes i32 data type to this variable, and it also considers this constant also as i32. So i32 plus i32 will result in another i32 value. So the compiler considers sum also as i32 implicitly. That's how it helps us to write the code without annotating the types explicitly. So it's a kind of a less verbose code. That's how you create the variable using the let keyword. Now you may be wondering, what if I want to mention the type of the variable explicitly? That is possible. For that, what you need to do is you have to use this syntax. Let's say I want to consider this variable as U32 value, that is unsigned 32-bit value or unsigned 16-bit value. So then I can mention the type explicitly. For that, you have to mention a colon here in front of your variable name, and then mention the data type. Let's say I mention U16. Please note that after this colon, please maintain a space here. So this is actually optional, but it actually improves the readability. This is how you explicitly type annotate a variable. Give a colon here and give a space, then mention the data type. Here is an example. For readability purpose, please maintain these spaces. Whenever you use the operators like assignment operators, plus, minus, multiplication operators, etc. So make sure that those are always surrounded by a single space here, and also ensure that the type name is preceded by one space. So now what happens? Will this code work? This will definitely work because now its type is explicitly mentioned, that is U16. This is also a valid U16 value 10. So U16 plus U16 will result in U16. Everything works, as you can see, it works. What if I don't initialize this variable? So what if I just leave at this point? Will this code work? Let's say if it's a C code or something, even though we have not initialized this value, so this could have worked in C programming language, for example. Maybe it could acquire some garbage value, but still it's going to work with some warnings. But in Rust, it is not possible to use a variable without initializing it. Here, this value is not initialized, so Rust is not going to assume any value, something 0 or something. This code will not work. As you can see, it says the value is not initialized. That's why it is asking you to initialize that value. You can initialize here itself like this, or you can do a late initialization, something like this, which is actually discouraged. So you can also do something like this, value is equal to 0. You can do this as well, but that is not good practice. You can initialize when you create the variable itself. And please note that the type inference happens based on the context in which the variables are being used. The context need not be a simple assignment like this. It could be any operation like arithmetic operation or any logical operation, or it could be a function call, etc. And it is worth noting that type inference is not always possible. If there is any ambiguity while inferencing, then the Rust compiler may throw errors. Then you have to explicitly help the compiler with the type. Here is another program. So here, when we run this program, very simple program, it prints sum is 15. Is there any ambiguity in this program as far as the data types are concerned? No, actually. As you can see, when compiler analyzes this code, the num1 is initialized with a constant integer, and so it by default Rust considers this variable is of type i32. This also as i32, and i32 plus i32 result is i32. So some variable is of type i32, and we are printing that. There is absolutely no ambiguity in this code. What if I mention the data type for this variable explicitly? So like I will type annotate u8 to this. Now what would happen? So now let's analyze this code. Here this is of type i32. So i32 plus i32, which gives us i32. I am trying to assign i32 value to a variable which is of type u8, hence there is a type mismatch. Will it throw type mismatch error in this case? Actually, the answer is no. This will compile successfully. As you can see, I'm going to compile this and it runs fine, no problem. You may argue that this is a small number, so the sum of 5 plus 10, even though it is i32 value, it can be fit into the variable of type u8 because it is well within the range of u8. So you may argue something like that, but that is not the case. For example, let's say I explicitly mention i32 for this, and I also mention explicitly i32 for this. Now, as you can see, it will trigger errors. Mismatch types. Why is that? The simple answer for this is Rust doesn't allow you to store a value of i32 into a variable of type u8, even though the value fits in the range of u8. That is not allowed in the language itself, as you can see, because that may introduce bugs in the program. As it clearly says, expected u8 found i32. So the one way to solve this problem is you explicitly cast it into u8 using, there is a keyword, as keyword, as u8. So you can do something like this. You know what you are doing. Compiler allows this time because you have casted it explicitly. Now let's get back to our original problem. That was this one. Why did this work actually? This works, as you can see. Here what happens is when Rust compiler analyzes this code, it actually observes the context in which num1 and num2 is used. Look at this line.
num1 and num2 are used to generate a value of U8. Hence, it internally type annotates these variables to U8, not to I32. If I print the data types of num1 and num2, that would print U8. Let's write a simple function for that. Here is a simple function which actually returns the name of the type. What I will do is I will just call this here itself, println type of num1. I'll just call this function type of, and then just pass the address of num1 here. Then we will also print the type of num2. Now we'll also print the type of sum. Anyway, sum is U8, that is for sure. Let's run. As you can see, it says type of num1 as U8. This is as U8, so it considers all variables are of same type, that is U8. So in summary, here the binding of num1 and num2 to the data types occurs after comprehending the context in which those variables are being utilized. This is the context here. So the context is to use num1 and num2 to produce a result of U8. Now let's talk about mutable and immutable variables. So let's say I have a variable. Let's say num is equal to 10. And let me print that. Very simple. Let me print the value of num. It prints 10, no problem. Then let me try to change the value of num to 20. And let me try to print again. So will this work? So this will not work. Let's try. As you can see, there is an error. Why? Because this is by default immutable. That means like it shows constness. As the error clearly says, cannot assign twice to immutable variable. This is immutable variables. That means once its value is fixed, it cannot be changed in Rust unless you explicitly mention it as mutable variable. Whenever you create a variable using the let keyword without mentioning the mute keyword, it is an immutable variable. So its equivalent C code would be something like this. It could be const int num is equal to 10, right? In C code. So in C code, what happens is you have to explicitly mention the constness of a variable using the const keyword. But in Rust, that is assumed whenever you create a variable using the let syntax. So constness is by default here. That is one of the safety feature of the Rust programming language. Now you may be wondering, how do I create mutable variables? For that, you have to explicitly mention the mute keyword after the let keyword. Let keyword, give a space, mention the mute keyword. Now this makes this variable as mutable. The equivalent C code could be something like this. I hope you understand that. And so now it compiles. You can change its value. So in summary, when the variable is declared or defined using the let keyword, please note that it is considered as immutable by default. This means that once the value is assigned to the variable, it cannot be reassigned a new value. So now Rust enforces strict type checking. Consider this example. Here there are a couple of variables. So the num1 is integer type variable and num2 is a floating point value. And you cannot multiply an integer type value with a floating point type variable or value. It is not possible in Rust. Suppose if it is some other programming languages like C, for example, then it is actually a legal statement. There you may encounter the implicit casting. So such implicit casting is not there in Rust. If you want to cast it, so you can cast it explicitly using Rust casting features. Now let's try to run this code and we'll understand why it doesn't work. First, let's try to compile this code, and as you can see, cannot multiply integer by float. Can we fix this code using as keyword? So before that, let's try to fix this code. It is I32, num2 is float, type actually. It is maybe F64. Then can we make F64 as I32 using the as keyword like this? So we'll put one parenthesis here like this. Now will this work? Let's say this is I32, so this is casted explicitly as I32, so it must work. Let's run this. Yes, it prints 80, no problem. But what if I remove this? When I remove this, there is no implicit casting, hence this doesn't work. When you try to run this code, as you can see, the error message is little strange. It says cannot multiply integer by float, and it also says no implementation for doing integer and float multiplication. No implementation, it says. After that, it shows a couple of help related information like traits and all. These are some advanced concepts, so we will be learning about this little later in this course. Basically what it says is trait, there is a trait called mul with this type that is not implemented for integer. What happens here is when Rust compiler sees this operator, multiplication operator, it actually invokes the mul trait implementation for num1. Num1 is I32 type. So compiler invokes the mul trait implementation of I32. We'll see that. Go to Rust official website, rustlang.org. Here you can access the standard library documentation. Here you find documentation and then the standard library. Go to standard library and here search for I32. That is a primitive data type. And here you see a section called trait implementation. Trait is nothing but it's a kind of interface in other programming languages. Basically, interface is like a contract, and that contract is denoted by set of methods by the interface. So if two classes, if they adhere to the same interface, then they must provide their own implementations of all the methods declared by the interface, like the mul interface. But in Rust, we call it as a mul trait. So trait is like interface. Traits or interface help us to write polymorphic code and to write object-oriented code. And we will study all these things as we make a progress in this course. So when you browse this section, trait implementation, then you will find trait named mul. As you can see, the I32 implements the mul trait. But on these types like I32 or a reference to I32. For example, let me just click this and here you can see that mul trait is implemented for I32. But look at the implementation, the signature of this function. This is the implementation and it takes another argument of type I32. So this has to be I32. Or it could be, as you can see here, another flavor of mul trait implementation for I32. It could be a reference to I32 value. That is also possible. Then it actually dereferences that pointer and it carries out the multiplication. But the mul trait implementation of I32 doesn't support float values as other argument here. Hence, the compilation fails. You can create, for example, your custom data type and you can give support for mul trait multiplying, let's say, integer and float. That's possible. You can create such data types, your own data types like custom data types. But for the inbuilt data type, that is I32, so the trait implementation doesn't support sending float as an argument. Hence, this fails. So as you can see, you can send a reference to the number. For example, let's say I create another variable num3 is equal to a reference. I'll use ampersand sign and num2 I'll use something like this. This is called as a reference now. and we'll understand references little later. But this is like, holding the address of num2. Now, can I do this? Num3, num1, which is of type i32, num3. If you're wondering what is the type of this, it will be ampersand i32. A reference to i32 value. Hence, this is of type pointer. It's like pointer type, like ampersand i32. Don't worry about this code. We will understand that a little later. But my point is, can we multiply these two? Num1 is of type i32 and this is of type ampersand i32. It works actually. As you can see, oh sorry, there is some problem. I cannot do this. This has to be num1, let's say. So num1 multiplied by num3. It works actually. As you can see, it says 400. So 20 multiplied by 20. But why this worked? Because there is a trait implementation available. As you can see here, there is another flavor of mult trait implementation for i32 which accepts argument of type ampersand i32. That's why, so this is of type, let's say f64, and this is of type, let's say i32, and the mult trait implementation of this type will be called, and it will be passed as an argument to that function, and that function doesn't recognize this type, hence there is an error. So let me create one string variable. A string variable, let's say hello. I'll call toString method on this. Don't worry about all these things. We'll learn about this later. So basically message is a string variable which can hold a string data like hello in this case. Can I do, let's say, another message is equal to message multiplied by 4? Can I do this? So that means I want to multiply an integer to a string to get copies of message or something, let's say. What would happen here? Let's try to run this code. As you can see, it says cannot multiply string by integer. Can I multiply string by string? Let's try. So let me just create another variable. Let me call this as message1, message2, message1 multiplied by message2. Is this a valid code? Let's see. Cannot multiply string by string. Now, the reason for this is very simple. What happens is this operator expects the mult trait to be implemented on this type, that is string type. Let's see whether such implementations are really available for string. Let's search for string here. Go to this string here, this struct string. This is a standard library data type to represent heap-based string values. Here, if we browse the trait implementation, you don't find mul. There is no mult trait implementation, as you can see. That means this type doesn't implement the mult trait. Hence, you cannot use this operator with the string to multiply that string by some other value. It doesn't support that. That's the deeper meaning of this error message. So cannot multiply string by string or string by any integer because there is no mult trait implementation defined on the string types. Now here we have another code. So just analyze this code. Do you think this code will compile? Actually, no, this code doesn't compile. What's happening here? First of all, we have a explicitly type annotated variable num1 and we are storing 4 bytes in it. That's fine because it is of i32, and then we are trying to print that. Very simple. So why would this result in any error? As you can see, it says literal out of range for i32. So what is the range of i32? Here it is. The range of i32 is from this value to this value. So this is the most negative number what you can save in a variable of type i32, and this is the most positive value, so the max value. This is the min value for i32. So you can also verify that using min and max values of the standard library. Here the compiler finds some unusual coding pattern. Basically, what you're trying to do here is you're trying to store a large positive value in i32, but that doesn't come under the positive range of i32, so it's the maximum value. That's why the compiler throws error here. If I pick this maximum value, I'll just copy that and I'll paste here. This should work fine. It works, right? So if I increase this to 8, for example, what happens here? So this wraps around this number range and it goes to its negative counterpart. That means the data misrepresentation happens in the source code. That's why by default Rust throws error for this, as you can see here. And this error actually derives from the lint check. Lint check is kind of static analysis tool used by the Rust in order to report any undesirable coding pattern found in the source code. So I would suggest you to read more on this, because your code undergoes some static analysis once you start building the code, and if the static analysis tool finds any undesirable coding pattern, it results in compile time error. And as you can see, it says this is on by default. That is actually one of the lint check. Deny signals an error after encountering a violation of C, and the value of C is overflowing literals. So this is a case of overflowing literals, and this attribute is on by default. That's why we couldn't compile this program successfully. Now if you want to override that, you can make this deny to allow. I can use that attribute here and I'll change this to allow. Now you will not see that error, and as you can see, this large value is actually wraps around to its negative counterpart, and this is the value now stored in the num1.